Hi, in this video we're going to prove some statements to do with the squares of consecutive integers. Now, it talks about in this question that we want the sum of the squares of any 5 consecutive integers. And remember, it's not enough to do it just for one particular example here. If you want to prove it's true for the squares of any 5 consecutive integers, we have to represent them algebraically. So what we'd start this proof with is, like, let's say, let the 5 consecutive integers be, and remember how we can represent consecutive integers, where if the smallest integer was, say, n, so we use n to represent just any kind of whole number, then what would be the next integer? Well, if, for example, you had 8, the consecutive integer after it, so the one after it would be 9. You're just adding 1 each time. So if you add 1 each time, n, add 1, you get n plus 1. What would be the next integer after that? We just add 1 again, so n plus 2, and then n plus 3, and n plus 4. So these expressions here represent 5 consecutive integers, all spaced apart by 1. Now it says it wants the sum of the squares of these. So we want to square each and add them together. So we're going to do n squared plus the next integer 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 squared. And then this expression here we want to show is divisible by 5. We'll see how we do that in a second. But for the moment, we just need to expand out all these brackets. So we've got the n squared. Now, do you remember the quick way to square a bracket if you've got 2 things in it? You do the first thing squared, so n squared. Then you do 2 times the first thing times the second thing. So 2 times n times 1 is 2n. So we add 2n. And then we do the second thing squared. So the 1 squared is going to be plus 1. So that's a quick way to square a bracket. What about the next one? We do the first thing squared, so n squared. We do 2 times the first thing times the second thing. N times 2 is 2n, and we double it is 4n, so it's plus 4n. And then we square the 2, which is 4. Then the same here, we square the n, so it's n squared. We times these 2 things together, so that's 3n, but double it, so that's 6n. And then we square the 3, which is 9. And then finally, we've got n squared. We times the 2 things together, n times 4 is 4n, double it is plus 8n, and then the 4 squared is 16. So now we need to simplify this. Let's collect the n terms together first. So n squared plus another lot of 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 n squared. That's 5 lots of n squared. What about the n terms? Where we've got 2n plus 4n is 6n, plus another 6n is 12n, plus 8n is 20 lots of n. And finally, the constant terms, the terms without a variable in it, we've got 1 plus 4 is 5, plus 9 is 14, plus 16 is 30. Now, we said that we need to show that this is always divisible by 5. And in a previous video, we showed how we can show something is divisible by 5 or a multiple of 5. We just have to factorize the 5 out of the algebraic expression. So we factorize out 5, put a bracket, and then, well, 5 times what is 5n squared? It's n squared. 5 times what is 20n? It's 4n. And 5 times what is 30? It's 6. Now, because n is a whole number, this expression here is a whole number, and we know that 5 times any whole number is going to be a multiple of 5, or divisible by 5. So we therefore have proved it. And because we're showing this is divisible by 5, and it's a proved question, you should probably at the end, just to be explicit that this is divisible by 5, you should actually just write which is divisible by 5. And that completes our proof.